Hi viewers, welcome back to my YouTube channel. I'm glad you made it. So today we're going to look at object-oriented programming. It's a concept of programming that is based on objects. So OPP, I put in lowercase, is a programming style that bases software design on objects. So it's a programming style that bases software design on objects. So you're going to have most of the application based around objects, putting data in objects and retrieving it from objects and displaying it on the user interface. So previously, we've looked, if you've seen the previous video, you've looked at how to create objects. And one way was the straight up method of using an object literal. Let me say, writing your object, const object1. I'll call it object1 using the equal sign to assign it, and then the curly braces. Then maybe you'd have property A, assign it a value of 1, and then property B, assign it a value of 2. Okay, so that was one way of writing objects. The second way was using the object constructor. Let me say const object2, using the object constructor, new keyword, and then object. And then assigning it value using either the dot notation or the curly brace notation. In this case, let me use the dot notation. I would say object2 dot name and then I'll probably call it a name, random name, say Shimge, and then object2 dot age, set an age maybe of 50. So those are two ways you write objects directly. You can either use the object literal where you write it directly, or using the object constructor. Whereas it's very practical to use this in a small demonstration or a small application. It is not ideal for big applications. So the above method, the above way of writing objects is not ideal for big apps because it's not scalable, reusable, and efficient. Okay, so that's where the concept of object-oriented programming comes in, OPP. So in object-oriented programming, we use classes to make models or templates for objects. And then from those classes, we can construct various objects where we can change the properties or the methods in that object, or we can make copies with minor variations. So we can manipulate our objects and create very many objects from one template. So that's where the OPP comes in, and for that we use what they call classes. So for example, let me start with a simple class. Let me say class animal. So this is how you write a class. You write the class keyword, the name of the class, preferably the name starts with a capital letter, and then curly braces. Okay, and to add properties to that class, those are the properties that will be inherited in the objects that will be made from that template. You just write the name of the property. So here we're initializing the properties and then the semicolon. So I'll say name, and then I'll write domestic. I want to know if it's a domestic animal. And then I'll say type of food. What does it eat? Okay, so those are the properties that are going to be in any object that we shall create from this template class. So classes have they have an innate method, a native method that is used to assign values to the properties in that class. So that method is called the constructor. So in the constructor, to assign values to the properties in that class, we use what they call the this keyword. So this keyword points to the class itself. So this keyword is pointing to animal, right? So if I want to assign a value to the name, I'll say this dot name, and then I'll assign it a value name, of which that name will be received here in the constructor. Okay, and then similarly, I'll say this dot domestic, then I'll give it a boolean value. That boolean value we shall receive it in the constructor here too, and then this dot type of food, I'll say type of food. I'll also receive that in the constructor here. Maybe let me say maybe food. Yep. All right. So now I have my template for creating objects. So now if I want to create an animal here, let me create my name const cat. I'll say I'll use the new keyword, then animal. So that is called instantiation. To make a copy of an object from a template, which is a class, that process is called instantiation. So I'm instantiating a cat object from an animal class. So I'll pass in my first argument as the name, which is going to be string of cat. Okay, string of cat. And then is it domestic? I'll pass in a boolean of true. And then the type of food, a string of meat. Yeah, cats mostly eat meat. All right, so I want to log that to the console. Since I'm going to use the console log so much, let me like my life a little bit easier. So console log is equal to the console object dot log. So you can just say log cat. I should be able to see it here in my console. So I have an object of cat that is domestic, true, the name is cat, and the type of food is meat. So I can also create another animal from the same class. Say const, let me say cow. I'm going to say new animal. The name, I'll give it cow. Is it domestic? True. What does it eat? Grass. So I can log it to the console. Cow. Should be able to see it right here. So you have animal, true, domestic, the name is cow, and the type of food is grass. Okay, and it's coming from the class animal. That's why we see the name animal here just before the curly braces. You can also create another class, const another animal. Sorry, let me say cheetah to be new animal, and then I'll pass in the name as cheetah. Is it domestic? It's false. What does it eat? Meat. So do that and log it to the console. Log cheetah. Should be able to see it here. So I have my cheetah here. It's not domestic. The name is cheetah. The type of food is meat. Type of food is meat. Okay. We got that. All right, so this is how you create an object that only has properties or keys, and then you assign values to it using a class as a template, and then you instantiating child uh, objects from the class, child objects from the class here. So a class can also have methods. Apart from the constructor method that is innate to the class, you can also add your own methods. Okay, so for this case, I'm going to use let's say a class post. So let me make a heading here. Class methods. Maybe adding methods to classes. Adding methods to classes. Class post. So I'll give maybe an ID to that post. Okay, so maybe something that I want to introduce in this case. You see, previously we have had to write the constructor. So the constructor, as I said, is innate. So you can either write it straight away and then assign values to the properties. So you can either first write the properties and then the constructor and assign values to the properties, or you can just write the constructor straight away and then use this sum notation, which will both initiate values within that class and also assign them values. So you can do it right away without having to first write the properties. So in this case, I'll just write my constructor method. And then, so this post, I want it to have an ID. So this.id, and I'll assign it a value of ID. And then this.info, what does it have? And then I'll give it info. And then who posted this.poster. And then assign it poster. The person that is going to post in that class. So I can give it a method. Okay. My method that I'm giving it is post description. What is this post talking about? I want someone instantiates this class and they call this method. I want them to tell us what the post is about. I want us to know what the post is about. Okay, so for that, let me log to the console. I use a template literal and I'll say this post of ID. It's going to be $, this.id, so that this keyword refers to the post class. Talks about this.info in our town and has been written by this.poster. Okay. Okay. In fact, let me call this person. All right. So that's one method. Now, there is another type of method that is available in classes that I should talk about, because static methods. So static method, I want to make this method, maybe let me call it post created. Post created. And then so I look to the console. Hey, yeah, I have created a post. Okay, so I have this static method. So a static method can be called directly on a class without first instantiating it. That is the difference between a static method and the normal method that you would write within your class. Okay, so let's look at it here practically. So say const my post, say the new word to instantiate it. Then I'll give it first argument. So in the constructor here, I need to pass in my ID. Just moving back a little bit, info, and then the person. So I'll give it an ID of one, and then the info is going to be current news. I'll make a string, current news. And then the person, I'm going to call the person Miyango. Okay. Good. So I've created my post. You can log it to the console here. My post. It's right here. So you have an ID of one. I have the info is current news, and then Miyango is the name. Okay. And if you look at the prototype, it has a constructor, which is on the class post. That's the init method. And then we have our method here, post description, that I've added. Okay. And then, so the static method does not appear in the prototype on the object. Okay. So I've created my post, I've logged it to the console. Now I want to call this method. So the way we shall call a method within, the way we can call a method within an object created using a class is that we shall have now, say, let me log to the console. So my post, then dot my method, which is now a property on my object, and then call it. And you should see it here. We should see what is being logged, this post of ID1, which is what I'm passing in here. It talks about this .info, which is the current news in uppercase here. In our town, and has been written by this .poster, which is the person, Miyango. Okay. Now where the static method comes in, we call a static method by just writing the name of the class. In this case, it's going to be post, then dot the static method, post created. We don't have to instantiate the post first for us to call a static method that is within the parent class or the superclass. So you can see here we've called it, hi, I've created a post. Okay. Yeah. So that's it. We got it. Now let's move on to another concept, which is called inheritance. Class inheritance. So for class inheritance, we're looking at how we can create a child class from a parent class, and that child class will be able to get all the methods and all the properties of the mother class or the parent class, and you can also add some properties and methods that are specific to only that child class. Okay. So for that example, I am going to use the animal class that I've created earlier here. Okay. So I'll say class lion. So to inherit properties and methods from parent class, use the keyword called extends. So extends animal. Okay. And then our curly braces. So first things first, we can decide to give some specific properties for this animal. Okay. The first property, we can say animal family. Want to know what animal family does it belong to? Let's initialize animal family property. And then the other thing is, let's say, is predator. Maybe shall receive a boolean to see if it's a predator. And then let's call our constructor method. So in uninherited class, when you write your constructor method, the first thing that you do is you write the super method. So the super method is going to call, is going to make available all the properties and all the methods in the parent class available in the child class. And as you can see, once I write the child super, it shows me all the arguments that go to the parent class. So on the name here, I'll give it lion, lion, and then boolean was, is it domestic? I'll say false. That is for the first. And then food, it's going to be meat. Okay. Yeah, so this is going to give these details to the parent class. Yeah. Then after that, we can now assign values to the properties that are specific to the lion itself, but not to the parent class of animal. So here we shall use this keyword dot animal family. You can say here family, and then is predator. We shall assign it a value of boolean. Boolean. All right. So then after that, I can also give it its own method. Describe animal. Describe animal. I'll log to the console. This animal is this dot name, this dot name, and it belongs to the dash. Let me say this dot animal family. Family, and it is dash is that is predator. It is that is dash is predator, and it is that is a predator. All right. Okay, I can decide to just okay. All right. So I have my custom method describe animal. So now let me instantiate that class. So if I say class lion1, I'm going to say new lion. So in my constructor here, I'll pass the family and then the boolean. Okay. Boolean. So I'm going to pass the family. It's going to be the big cat. Big cat family. And is it a predator? It's going to be true. So if I come here and log to the console, lion1, should be able to see it. Awesome. Here it is. So as you can see, we've inherited methods from the parent class. Domestic is a method that is available on the parent class. Sorry, is a property that is available on the parent class, not method. And then predator is only available on the child class. Name is a property that is available on the parent class. And then the type of food is a property that is available on the parent class. So we've inherited them in the lion class, the lion child class. Okay. So you can either say parent class, child class, or subclass and the superclass, or superclass and subclass. Okay, parent class being the superclass, the child class also being the subclass. So here it is. We have the lion, which is a big cat. We have the animal family. It's right here. It's a property only on the child class, and then its predator. Um, its predator true being also a property only on the child class, and then we've also been able to inherit uh, the properties on the parent class. And then if we go here, we can see our method that is only specific to the lion class, child class being describe animal, and here it is. And if I call it, well, it's going to be lion1 dot describe animal. It's going to be here. This animal is a lion and it belongs to the big cat family. Let me make this uppercase maybe, just for illustration. This animal is a lion and it belongs this dot name. Yes, it's a lion coming from the name, this dot name, and it belongs to the big cat coming from this dot animal family, and it is true coming from this dot is predator, that it is a predator. Awesome. Okay, so with this, I've talked about classes, how to write a class, talked about the constructor method, talked about inheritance, the relevance of the super method under the constructor once you're inheriting properties from a parent family into a child class, from a child parent class into a child class. And I've talked about how you can add your own methods into your class that can perform different functions depending on the object that you'll be instantiating from that class. Yeah, so that marks the end of my tutorial about OPP, object-oriented programming. It is not exhaustive. There are other concepts like encapsulation, um, where you can have some methods and properties only available in the parent class but not in the child classes. In that case, you'd use keywords like private. You can have a private property and a private method. You can also make them public. And there's a lot more you can actually look up about classes. For application development, you mostly use this logic for like 90% of your use cases. So this will be enough if you're developing an app. Like 90% of any use case, you need basically how to write a class, how to inherit, and how to add specific methods. That is what is very important. The rest is good for knowing, but I've not come across it as having too much applicability in when you're developing apps, unless if they're very complicated apps and you have some little specifications that you want to do with those other extra features. So with that, thanks for watching. I hope this video has been helpful. I'll see you in the next one. Bye bye.